All right, here we go. Algebra 1, Chapter 1, Section 7, Functions. Okay, don't write this down. This is the book definition, but we'll have a look at it. A function is a relation that assigns exactly one value in the range to each value in the domain. That's a little confusing, so remember this. No value in the domain can be used more than once. Go ahead and write that down. No value in the domain. That means no x value. Okay? No x value. Remember, domain x, range y, can be used more than once. So if we want to analyze and see whether it is a function, let's look at this relation right here. We'll look at all the x values. Really, I am not interested in the y values. Let's just look at the domain, just the x values. Notice here, 3 is paired with 0, and 3 is paired with 2. And since we said no value in the domain, no x can repeat, no value in the domain can be used more than once. Since 3 repeats, this is not a function. If I were to look at it on a mapping, I have 3 is with 0, negative 2 is with 1, 0 is with negative 1, negative 3 is with 2, and then 3 is also with 2. Notice right here, 3 is paired with 2 values. We don't care about this right here, the range, that doesn't matter. All of these could be paired, could be 2, but what we care about is the domain. No value in the domain can be paired more than once, and notice there are 2 pairings coming away from this value, so this is not a function. There's the vertical line test. If you have a graph and you are to determine whether it's a function, you can do the vertical line test. If I take a vertical line, you can use your pencil. Sometimes this is also called the pencil test, the vertical pencil test. You lay it vertical, and then you move it left to right. If it ever touches more than one point, it's not a function. In this case, it only ever touches one point as I move it across. If I go to this over here, I take my vertical line, and I notice right there, it's touching up here as well as down here. The vertical line touches twice. So if I were to look at this, take my vertical line, move it across, notice it only ever touches in one point. This is a function. Test this one. Oh, suddenly it's touching in 2 places. So notice we're touching up there and down here. This is not a function. Is this a function? Well, right at this point, notice this is filled in. That means there's a value here. This is open, so there's no value there, which means it's not touching here. It's touching down there. This is called a step function. This is a function. This also works if you have a scatter plot. If I move this vertical line across, touches 1, and then right here, touches 2 points, so this is not a function. I could graph this. If I have 3 and 0, graph 3 and 0, negative 2 and 1, 0, negative 1, negative 3 and 2, and 3 and 2. My vertical line test would show me right there it touches 2. Remember, this is the same relation from the beginning. We have 3 and 3 repeating, so that is not a function. Now, equations that are functions can also be written in what's called function notation. So instead of the y, instead of writing y equals 3x plus 2, which we call an equation, we would write f of x. Notice y and f of x refer to the same thing. X is the domain, y is the range. So in this case, x is still the domain, and y, which is f of x, represents the range. If I want to work with functions in function notation, they might say, evaluate f of x equals negative 3x minus 10 for x equals 6. So if x is 6, we can replace x with 6. So instead of x, I'm going to put 6 right here. And then instead of x, I'm going to replace x with 6. And then evaluate. Multiply. Negative 3 times 6 is negative 18. Minus 10 is negative 28. So f of 6, the function value at 6 for this function is negative 28. Evaluate f of n, for n is negative 4. So I have n is negative 4. I'll replace this with negative 4, and then evaluate. The first thing I have to do is evaluate the exponent, because this exponent applies only to the n, only to what's directly in front of it, so that's negative 2 times positive 16. Negative 4 times negative 4 is positive, plus 7. Multiply, we get negative 32, plus 7, and that is negative 25. So f of negative 4 is 25, negative 25. If I have x is r plus 1, suddenly we have an expression. We do the same thing. We replace x with r plus 1, and then we evaluate. We have to do distributive property here. That gives me 5r plus 5 plus 3. I simplify what I can, which gives me 5 plus 3, 5r plus 8. So g, the function g of r plus 1 is 5r plus 8. I can't combine these two because this has a variable and this does not. I cannot combine a variable term and a constant. I do want to look at this last case here, adding two functions. So I have, for number 3, f of negative 1 plus g of 2. So I'm looking at the function f of x, where f is negative 1, so I'm going to replace x with negative 1. That gives me 3 times negative 1 minus 5. This entire expression plus negative 4 times 2 squared plus 1. Now evaluate this. 3 times negative 1 is negative 3 minus 5. And then 2 squared is 4, so plus negative 4 times 4 plus 1. Do the multiplication next. Negative 3 minus 5 plus negative 4 times 4 is negative 16 plus 1. This right here, plus a negative, means minus. So now I have negative 3 minus 5 minus 16 plus 1. That gives me negative 8 minus 16 plus 1. Negative 8 minus 16 is negative 24 plus 1 equals negative 23. So you can evaluate this too. And that was section 1, 7 functions.